Everybody, welcome over to our contour topographic maps. 1.05 topographic maps part 1. This is where we are going to go over the actual lab portions of this content area for you. And this is the top map on 1.05 topographic maps part 1. If you don't have A, B, and C on your map, then I'm going to welcome you to snip this screen right now or go back into 1.05 topographic maps part 1 and download the digital materials once more. For some of you, this A, B, and C did not stick, so I think you were sort of guessing as to what the elevations were and such because you didn't have these markers. So we're going to see if we can get you a better grade by going over this together with a lot more detail. So in number 1, it says in front of you is a topographic map, which we know that now. This is our topographic map. And these types of maps show details about the natural environment and elevation. Who might use one of these maps? This is something where I want you guys to do a little research. You can look at the Map Web Rangers website. That would be in the email where I've sent out this help video. You could look in just go to Google and say who uses topographic maps, and it will give you some ideas if you don't already know. And then number 2, look at position A, okay, on the map. This is called a contour line, and it shows the same elevation for any given point on the line. And A happens to be an index line because it is darkened, okay? What is the elevation at A? Well, we know that if we follow a contour line around, every point on this line is the same elevation. And if we look right here, that's the elevation. And this is a 1500, so 1,500 feet, or kilometers, or meters. The units are not on here. So you can just put the 1,500 right here. For number 3, we're going to look at position B on the map. Sometimes the line doesn't have an elevation written near it, or the elevation is written somewhere else on the line. Follow it around. If the line is darker than the other lines, it is called an index line. So we're going to find B, which is right here, and that arrow is pointing to this line here, and there isn't an elevation when we go this way. So we're going to follow this line on around. We're going to go behind C and keep traveling. We just have to keep ourselves on this one line. Train our eyes to this one line. And we're going to follow it around. And hey, look, there's our elevation. And if we look, that elevation is right here. And so we're going to write this number, 1,600, this number right here, right there on your lab report. Now, the distance between lines is called the contour interval. And for this one, we have not been given the contour interval, so we have to find it. And in order to do that, we need to find 2 known elevations. It just so happens we know A and B. We just found those. So we're going to subtract one from the other. So what we'll do is we'll subtract A and B. And our higher elevation was 1,600, so we'll put that on the top. And we'll subtract B, which is 1,500. And that equals, let's go through this, 0 minus 0 is 0. 0 minus 0 is again 0. 6 minus 5 equals 1. And 1 minus 1 equals 0. We don't have to put a 0 here because it won't change our number. So that's not the contour interval, but that is the change in elevation between A and B. So this is, right now we found the change in elevation between A and B. It's 100. In order to get to the contour interval, we need to divide this number by the number of spaces between them. And we have to be really careful when we're counting those spaces because it can be tricky to see. So we go to A and we start counting. This is one space right here. This is a second space. And then we have this third space, a fourth one, and a fifth one. And then we get to B. So there was 1, 2, 3, 4, 5 spaces between line A and line B. So our contour lines, A and B. We had 5 spaces. So we're going to take 100 and we are going to divide it by 5. And that equals a number. I'm going to let you do that on your calculators, okay? And that will give you your contour interval, okay? That's the contour interval. It's important to follow through with that last step there. Okay, so we're going to move on to numbers 5, 6, and 7. What is the contour interval of this map? Well, we just found that in number 4. So you can write that number right here. After you've divided that 100 by 5, you can put that number right here. What is the elevation change between position A and B? Guess what? We found that in number 4 also. That was that first step that we took. We subtracted the elevation of B and the elevation of A, and that gave us our change in elevation between points A and B. Write that number here. What is the elevation change between position A and C? Okay, this is a little trickier. You found a contour interval, and what you have to do is count by that contour interval. And let's count how many lines are between A and C. I'm going to give you guys a little hint, okay? Right here, this is 100. We know between these index lines, that's 100. So this would be 200. And then there's 1, 2, 3 more lines. So you would count by this number 3 more times and add it to your 200, and you would get that change in elevation between A and C. So again, we go 100, 200, count by the contour interval, count by the contour interval, count by the contour interval, and it gives you that change in elevation. Okay, so 8 is a recap. When contour lines are close together, it is an indication that the slope is steep. When the contour lines are farther apart, the slope is more gradual or gentle. Which direction is the steepest slope facing on Enchanted Rock? I want you guys to look and really notice. This is north, east, south, west. There's a northeast, a southeast, a southwest, and a northwest. And if we come around here on this map, look for where the contour lines are so close together, they're almost blurry. Okay? We want really, really close together contour lines. So they almost look like a red blob or a brown blob of some sort. Okay, and look right around this Enchanted Rock. All right, that will finish off part 1 of your topographic maps lab. Part 2, you are supposed to pick a volcano, and you can use an elevation map that's color-coded and draw circles around it. You can use paint, you can use PowerPoint. These can be just straight circles, okay? I'm okay with that if you're not good with a paint program or a drawing tool, all right? You can also come into our help session from 1 to 2 and ask to use a whiteboard, and then you can just snip from there. And so this would be a topographic map of an island, okay? And it is labeled with elevations, okay? And that's really important. I'm going to include this right here. This is a website where you can explore topographic maps and create your profile and your map on this page also. It's a really cool program. So if you're not an artist, that's a great site to go to. When you're making the profile, you can put a white box over all of this right here. If it doesn't match your topographic map, that's okay. Just put a white box over it, insert a shape and put it there. And then you're set up to begin your profile. I'm going to have to do that. So I'm going to, because these numbers, they don't match up. The 0 does, but the rest of it does not. So I'll just make a new a shape, and I'll just create my own because mine goes by 10. So I'm going to label every other line on here, and I'm going to label 20. So I'll put this here. So this would be 0, 10, 20. And then I am going to need a couple more of these. So hang on while I make these. 40. And I have room to label another one, so I'm going to do that. Just like this. And then what I'm going to do is I'm going to start drawing vertical lines. And nope, I'm sorry, I have to pick my path across this island. So I'm going to draw the path that I want to take across the island right there. And every time I cross a contour line with my path, then I'm going to draw a line that goes down, okay? And so here we go. This right here, I'm going to start with the outermost line because this happens to cross my path and contour line. So I'm going to drop down to 0 because that's what my elevation is at this point. Okay. And then if I keep walking across, I will, oops, look, I ran into another contour line. So I'll have to insert another line. But this one is at 10. So I'm going to go to here instead. And then if I keep walking, oop, look, I hit another contour line. And if I follow this one around, this is at 20. So I'll insert another line at that intersection. There. And then I'll keep walking my path and oops, I hit another one. So I come all the way up here and that's at 30. So I will drop another line. So it comes here. And we'll keep going like this. Every time we walk across the path and run into a contour line, we'll figure out what the elevation of that line is and drop a vertical down to that line on our profile chart. Eventually, right like that, we're going to come to a place where we're dropping it. Oops, hang on, we go. You come to a place where you're putting them at the same height. That's probably the top of your hill. And after that, you're probably going to be going downhill. On this particular one, I'm not. I'm going to just remain at 40, which is interesting. And it will create an interesting profile. And if we keep going, oh, look, we're going uphill again. So this is 50. I'm almost out of recording time. So I'm going to do this really quickly and show you. When you're done doing all of this, because you have to keep going until you get to the other side of the island. So you would keep drawing these lines. And then you will actually connect them to create the profile. So you connect the endpoints of these. Now I know that my hill is going up, 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 and it's going to go up, but it won't reach 50 because we didn't get to a new contour line. And then it will come down, and it's not going to quite reach 30 because we didn't go anywhere, so it sort of plateaus out. And then it goes up again, and then it's going to come back down again over here. I know that because I can see here I'm going down in elevation. And by the time I'm done, I'll have a finished profile, but you can see the first half of my profile here. So this is how you draw a profile that is a topographic map. And I will let you guys answer the rest of the questions on your own. If you have any questions or need help, you can always call, text, or email. Thanks for listening, guys. I'll see you in class.